Hey there learners, we are back with the second part of the Detect Parkinson's Disease by Machine Learning project. Do you remember what we covered in the last video?
That's great if you do, but if not, this is what we covered. What is Parkinson's disease is? What are the symptoms? Understanding of perspective. Understanding of problem statement. How we did the pre-processing part. If you have any questions, please check out the description for the first part. Are you wondering what we are going to cover in this video? Well, we will cover logistics, random forest, bagging and boosting, stacking, kernel support vector machines.
Hey, also, don't forget to wait till the end for the best part as we will also cover the most asked interview questions only for you. Let's continue to take a look at the detection of Parkinson's disease project by machine learning.
Right, everyone, are you able to see my screen, my dear friend?
Yes, sir. Yes, sir. Yes, sir.
Okay,
Yes, sir,
so what I'm doing, just let me start. So pre-processing part completed, right? Okay, so pre-processing part completed, my friend. Now, just let me check the data set. We have x dot shape. So we have total 22 variables, my friend. 22 attributes, I can say, right? Because x is independent variable. And dependent variable is whether patient has Parkinson disease or not. And that's the objective is, my friend. Yeah. If you think about the data point of view, then it's a very simple data. We have a very less data, very simple variable. But if you talk about the real-time perspective, then it's a very, very good problem, right? But here, since we are doing in class, so we have a less data. But in real time, when you do it, my friend, any company, right? And especially if you work in clinical sector, you will get so many data, say 290,000 patients to 5 lakh, like that. And most of the time you will use the system where you have already GPU is enabled. Because you will handle all kind of things, right? You will use machine learning, you will use deep learning, you can do the automation kind of things, everything you will do it. So for processing point of view, you have a very, very powerful system where you have a GPU is already installed. But here you can just think about it's a not big deal, right? It's a very simple data set, I can say. But only things you have to remember about the project, what type of problem you are doing it. So maybe next week when I pick the project where you will get, minimum 5 lakh or 10 lakh data set with the different varieties of columns, variety of attributes. So maybe I will go in the finance or banking domain. You will get a notification on Wednesday. But this data set, if you talk, if you just think about data science perspective, I can say it's a very simple data set. So purpose is not simple or difficult. The purpose is you have to understand how you will process it, right? This is just a number for me. When you do the such problems, sometimes you will get here 20,400 or 2,94,000, and the attributes is okay. 22 is not, less for machine learning perspective. Lots of cases you will do when you will get 7 or 8 variable only. Now, one thing, always you have to do, this is the feature engineering techniques, right? So when you say I did the pre-processing part, I did the EDA part, I also suggest whenever you handle such classification problem, please do PC also, right? What is PCA? It's a principal component analysis. It's a part of dimension reduction where your system, right, where your data will ensure that whether my variable is significant or not. So let's say if the data set is here, you can see that this is what my data set. Okay, this is what my data set. And if I do this part, I think I have not done, it's there. Yeah, correlation part already we did it. All right. So, here also you have seen, I have already discussed dependent versus other parameter, where I can see there are lots of, the correlation between other variable are same. So can I check, do we really, some of the non-significant variable there, which is not required. So how you will do it? There is a technique called PCA, right? If you guys have already learned, very good. If you have not, my friend, for them, just I'm giving. This is called feature engineering techniques. What PCA will do? PCA, whenever you have a multicollinearity there, you can apply PCA and all the multicollinearity data get removed. You will get only, let's say there are 5 columns there, which is multicollinearity between each other. So if you apply the PCA, 4 data get removed, only 1 data you will get it. So like that, let's say A and B is connected to each other, then B get removed. C, D, E, all 3 are the same data and impacting with the same result with dependent variables. So, D and E get deleted, you have only C there. So why not you can write one more line code and you can see, right? So I think last session also I did PCA. Here also I want, you can just go and apply PCA. So you can say applying PCA principle. For safer side, always go. So you can say from scale on dot decomposition import PCA, principal component analysis. Now you have to write one object. You can say PCA equal to principal component analysis, and you can say, I wanted to retain 95% of the variance, right? And 5% variance, which is non-significant, you can drop it. So you have to give here 95%, right? So you can say 0.95. 0.95 means 95% significant variable, I'm considering it, and 5% I'm removing it. Yeah, wherever the variance there, this is what you can do it. Then PCA x underscore PCA equal to, right, PCA dot fit underscore transform.
But
and you have to put
PCA, how will come to know which variable is significant?
That you will not get a visibility. That is the only barrier there in PCA, because it's internally, right? If you guys know mathematics, but that's why I said if you have learned, then you know that, right? If you have not learned, then definitely you will learn in class, then you will get to understand what happens. So just PCA is a techniques where you don't have visibility, because PCA is not working column wise. PCA is working by value wise also. So in data set, let's say we have certain variable is there, yeah, certain variable is there, and there are some variable, let's say A is given, and I have not handled the missing value, and this just I'm giving a perspective. And let's say we have here given 10, 20, and this is a question marks, okay, and this is any value. When you apply the PCA, automatically this get removed, automatically this will get removed, and only these 3 value will come. Okay, and like that, some value here also, let's say some significant value there, that value come here, and what they will do, they will find the eigen value and then eigen vector, and accordingly they will give the result. Yeah, so it purpose is to find the significant, when I say 95% significant value, not column. That's the properties there. Okay, so if you know PCA, you will you know that you don't have visibility which column is there. You can say only the significant value came. Are you with me?
Yeah. But if I want to predict a new data point, new set, how I can But
Huh,
you
then
can't
don't
consider-
do. No, then don't apply this. You can directly go here, split the data into training and test, see what happened. Whether your data is getting a variance, high variance. What is the biggest challenge in machine learning? High bias and high variance, right? So if you
Yes.
see the high variance, what is your understanding? Maybe whatever the value there, I have taken all insignificant variable when we trained the model. There are certain value which is, I have taken for prediction. That's why my result is coming very pathetic. So what engineering techniques I can apply? There are some unwanted variables there, unwanted values there. Are you with me or not?
Yes, yes. Here also we are going to predict Parkinson disease, yes or no, right?
Correct. Yeah.
With unseen data.
Yes.
Even for unseen data also, do we need to apply PCA and split it, or
So I'm only applying with the independent variable. What are the significant there? I'm not touching the dependent variable. In independent variable, which variable is the significant one? Not variable, which values are significant. Okay. And that we have to take it.
Sundaram sir, can we do a explained variance ratio just to find out the which features are important and which features
No,
are
then you can do a lasso method. No, lasso will give you a visibility. But I'm not doing this. Lasso will give you a visibility. It will what it will do. Any variable which is non-significant there, then that what it will do. That will automatically will become a zero. So you have a visibility.
In class, you have explained just to find out the explained variance ratio, where we are getting the log values and all, and we are trying to check which features are having a better impact on the dependent variable, and like that.
So any model you can do the logistic regression. You can just say summary. No, when you do a summary, you will get the visibility. You will get a p-value.
Sure.
Don't try to use this. Let me say I'm not doing this one. Okay, for the timing, you can just leave this one. And you can just go and apply the logistic regression. Okay, so I'm just doing it from sklearn dot.
then PCA is for just learning purpose only? Then
Not just learning for purpose, to getting a better result, to getting a better accuracy.
yeah, we'll get the accuracy, but doctor come up with new values, right? You don't know the PCA and everything. If we want to apply on that variables, this model won't work, right?
This model want to apply. I didn't get what you mean.
We have the data set, seen data set, and we applied PCA for with 95% significance. We have done all the thing. We trained the model.
Correct.
Then, and doctor is going to enter original values, right? After converting PCA, he is not going to apply, right? But how the model will detect?
So this is what I'm saying. No, you don't try to use PCA. You can go by simple method, what you know. Okay, and you can see the result. Do we have any impact in the variance? Why I'm confident here? Why I'm saying? Because I did heat map, right? And there you have seen, yesterday also I have shown you. Lots of independent variable, their value are same.
Sir, instead of logistic regression, just go ahead with PCA only. We can get to know. We will have a better visibility also. Just go with PCA only. Then you can apply logistics or any other.
I also support this. You go as per normal flow. What you have planned to.
Correct. So my friend, anybody wanted too much, if you guys have not learned PCA, and if you have learned and then also you are asking, I wanted to see this, then I would suggest, please don't skip this and go by lasso method. See, you will see which variable is non-significant. And then you have to apply this. Okay. But this is the best techniques I'm telling you. Whenever you do such cases in industry, right? You have a visibility here. In beginning, when I did pre-processing, that time itself, you have a visibility. What are the variable I needed? That already they have given. No. So who has given this? Why we have collected? The doctor only, expert only, SME only, they suggested that these are the parameters I have to check. Yes or no? After that, we are the technical people, right? Data scientist people, we are doing engineering techniques. Are you with me?
Yes, sir. Yes, sir. Sir, go ahead with PCA. Sir, go ahead with PCA, please.
Okay. So you can see I'm doing PCA then. And now you can see here, my friend, just these two lines you have to write, and then you can apply whatever model. You can say print x dot shape. Okay, this is my original data set. Now I'm saying print and x underscore PCA dot shape. And you can see what is the difference happen. See, in original data, how many variables there, my friend? 22.
22.
And once we apply this PCA, how many variable now we have?
8.
8. So that means we have, how much data, how much columns you removed it. That's the benefit you have. Just 2-line code and they removed it. Also, if you go and manually also you can check it. I told you yesterday that you can see this is my dependent variable.
Yes,
This
sir.
is my dependent variable where it's status. This one. See, this is my status. Status, and you can see this one. So definitely I have to drop it. You can see 27 and 27. We have to drop it. See? We have to drop it. Yes or no?
Yes, sir.
So like that, there are so many values there. I can drop it. I can see same value is coming. So I have a confidence that we have to drop it. So the same thing happened, and after that, I'm getting only significant one. So that is my now, original data you have. And here you can play with this. You can build a model. So now you can go and do this.
Can I ask you a question, sir? Here,
Please.
After feature scaling, we did the fit transform of the random oversampled version of X, and we scaled that. So I'm like, are we going to use that scaled version, or we are going to simply use the X part in NPC?
I've used X only, Here I have a scaled version only.
Okay, you restored that. Okay.
Yeah, X only I have taken, no.
Oh,
So always go by a scaled one. Don't go by unscaled.
okay. And one more thing, sir. I got your point when we were talking about the confidence interval part of 0.95, right? In PCA. So, but somehow I was not able to visualize it. So maybe at the end of the class, can you share some light on it, or right now?
Sorry, I didn't get. What visualize you wanted to see?
There's this PCA, like I cannot visualize it mentally, like how we are building a confidence interval of 95. Right, I get the part where we can imagine that
you
normal
can just see
distribution
here X underscore, okay, and do here PD dot data frame, and this is your PCA. Execute this. See, these are the values there. How many column total? 8 column you are getting. Right. So this is actually array value. Now the value gets changed. You can see how this value calculation happened. Now this is called eigenvalue and eigenmatrix.
Yes, sir. That's the part I'm not able to connect.
Yeah. Oh, so then you have to learn. It's something that I will cover in here. In this batch.
Like I have learned, like we use the scaled up versions of it, right? In NPCA, and we check what variables. Okay, now I get it. Thank you, sir. Maybe your push was needed.
Okay, guys. So now you have to split the data into training and test. So you can say from sklearn model selection, import train, test, xtrain, xtest, ytrain, ytest equal to train, test, split. Here you can say x comma y comma x, what I have written, x PCA, right? So you have to put here x underscore PCA. Y test size 20% and random state equal to, let's say I'm writing 1. Yeah, so I have done this. Training and test, I have splitted it. Now you are ready to build a model. Okay. So here I am doing a bit model building. As I promised yesterday, my friend, I am going to use most of the model for machine learning. If time permits, you guys will not ask much question, then I will write neural network also. Okay, deep neural network also I will show you how you can write it, and machine learning also I will do it. Is it okay? And then you have to decide which model you will choose and go ahead. And that is what you can apply in the, whenever you do any project, you know, you can also apply, you can do the intuition, and then you can decide which model I have to go. So shall I go first machine learning and then I will jump into deep learning, so that one case study you have full, you know, understanding, full at what all things you can do it.
Yes, sir.
Yeah.
Yes, sir.
Okay, perfect. So what you have to do here, you can just import sklearn, import confusion matrix classification report accuracy score. All right. Your evaluation matrix, my friend. Confusion matrix, I hope you know. Performance matrix, classification report, you will get recall, precision, and F1 score. Yeah. Accuracy means you will get the accuracy part. So you will not trust on accuracy here because it's an imbalanced data set there, right? I have balanced it. So my main target is classification report. I will give focus. In fact, this one also you will give a glance, but you will not blindly trust on accuracy part. You have to give a glance here also. And this is a clinical data set. So which model is the best model for clinical, guys? If you have attended my session machine learning, or if you have already completed, which model is the best for clinical sector? KNN is the best, right? So one thing I'm pretty clear that KNN is the best. But learning purpose, my friend, I'm using everything. Yeah.
Yes, sir.
So what I'm doing here, I am saying list of matrix equal to blank. Okay, I don't know what is this. And then I'm saying list of accuracy equal to blank. I don't know what is accuracy. Blank object I have created, and whatever model I'm building it, I will, you know, put it here in list matrix and then a list accuracy. All right. What is the first classification model, my friend?
Logistic
regression. So I'm going and doing this logistic. So if from sklearn dot linear model, because logistic is a generalized linear model, LF. Yeah. So I'm saying linear model into logistic regression. Say classifier equal to logistic regression, copy paste, and then if you want to write a parameter, my friend, you can go and write a parameter also. What you do, run this, and you can see what are the parameters there. Here you can just say shift and tab, and you can see here it's given penalty equal to L2. What is L2, my friend? Anybody? Ridge or lasso? Ridge. Okay, you can see here some parameter also given. See, now you are not clear what is this, then I would request everyone, I will not go and teach you all this thing. Okay, you can just go and read this part, parameter. Here it's given parameter. So what is the penalty meaning is L1, L2, and this. So here my model in linear and logistic, already we are using ridge model, right? Here you can see already we are giving by default L2 model. But if you wanted to change, you can put it. What is the meaning of other? Everything you have to go and read it. Or if you don't know, then there is a question marks that you don't know the theory part. So just make a note. Either you can attend my session. I have started today only in the morning 8:30 batch, statistics batch. You can join that batch. Or if you are already learning, please make sure that you have to know this part. Okay, because if I pick logistic alone, I need minimum 2 days session, 6 hour session. I'm not going to discuss all this thing. Can I expect that part, my friend? Your support?
Yes,
The
sir.
theory part, I'm not picking it, right? I'm going in the coding part, the project part, end to end, how we can do it. But theoretical, whatever the parameter there, what is the meaning and all. One, if you already know, very good. If you don't know, please try to understand. Go here, use the shift and tab button, and then you can click this plus button and read it. What is the parameter it's saying it? Okay, all this thing is given very simple language. You will able to understand. Some technical words L1, L2, if you have not learned, you will not understand right now. So I'm just going by default. Or if you want, I'm just giving parameter C equal to 0.4, 40%, right? Maximum iteration equal to, I'm giving maximum iteration equal to 1000. Okay. And here it's already given. L2 is by default, so I'm just going by L1. Here C equal to 1, I'm just change it. And here solver equal to, they have given linear based model. What I'm doing here, I'm saying LGF DS, I'm saying library linear. Okay, lib linear. And then my friend, you can say classifier dot fit X train, Y train. This is my model. After that, what you do, you can just do a prediction. Say here prediction. And what prediction? You can write Y predict equal to classifier dot predict, and you have to pass here, my friend, X test. If you want, you can do train also, and you can validate it. But right now, my purpose is first, I wanted to find which model is the best model, and then I will do train and test both. Yeah, so it will save time also. Next part, my friend, once this part is done, you can say accuracy. Here you can say accuracy of logistic regression equal to accuracy store. Right now, I'm just going accuracy, but I will do classification report. Here you can say, my friend, Y test, comma, Y. Okay, so this is my one model. This is my model number 1. Model 1. Okay, this part is done. Now what I'm doing, my friend, I'm going the second model. Model 2. What is the second classification, guys?
Decision tree.
Decision tree. So you can say from scalon dot tree. Import decision tree classifier, and can I say classifier 2 equal to, my friend, decision tree parenthesis bracket, and by default you can see here, if I run this part, if I execute this, and if I go here shift and tab, by default my system will take Gini. You can see here, by default my system is picking criteria equal to Gini. But if you want, you can change entropy also. But I will not trust on decision tree because I always go by random forest. Random forest is the best. So here you can leave it, right? Either you can go by entropy or Gini. It will give only one tree. One decision tree you will get it, my friend. Only the parameter gets changed.
Yes, sir.
Yes.
Yeah. So I'm saying, okay, I'm not going to give Gini or entropy. I'm going by default only. Yeah. If you want to fix it, you can go and fix it here. You can see this random state given. You can fix that. That my decision tree, when we run multiple times, my answer remains same. So here, if you want, you can give some number. Let's say I'm giving 40. All right. Now what you do here, you can say decision tree equal to classifier to dot fit X train and Y train. And next part, my friend, what you will do? Prediction. Can I write here? Y predict 2 equal to classifier 2 dot predict, and here I'm writing X test. Are you with me?
Yes, sir.
Yeah, then you can say evaluation and copy this line, paste here. And what happened? You can say here instead of LR, can I put decision tree? And here, my friend, can I say 2?
Yes, sir.
This line is not. Are you with me, everyone?
Yes, sir.
If I'm writing decision tree here, decision tree for our safer side, then you can write here also LR, logistic regression equal to this. And I input, no, I will not do right now. I'm just doing all, and then I will apply everything and it will be stored, and then I will show you. If you want it, you can go here and do this separately.
No, we have to import metrics, accuracy score for metrics.
This one. You will get the accuracy score 96%.
Okay, it's already imported.
Okay.
Sir,
So
there
everything I'll
above
do.
LR, I think you put in a wrong place, sir. Yeah, classifier dot fit LR.
Here I'm putting LR equal to this. Is it okay? All my friend. Next part is what? Model 3, guys.
Random forest.
Model 3 is random forest. So can I say from sklearn.ensemble random forest classifier, and then can I say classifier 3 equal to random forest parenthesis bracket, and here also, my friend, what I'm doing, we can just go say random state equal to 14 copy and paste here. If I'm not giving any parameter, can I say by default criteria is Gini only?
Yes.
Yeah. Can I say here, my friend, the criteria is Gini? Yes or no? So you can just go and say random forest information equal to classifier 3 dot predict, and can I put here, my friend, not predict, but build a model. So dot fit X train, Y train, and then my friend prediction. Can I write prediction is Y predict 3 equal to, my friend, classifier 3 dot predict and X test, and then evaluation. Copy this evaluation part, paste here. Copy this, paste here, and evaluation. Can I write here random forest information? Here can I put? Anyone have any problem?
Sir, I have a doubt in line number 27. Why we have equated it with a variable RFI? I mean,
Very good question. Because, my friend, I'm just doing one by one. And at last, what I will do, everywhere I'm giving some notification name, no? LR, DT, RFI, RFE, like that I will give it. And all I will combine the voting model. So that at one go, my machine will run and all result will come.
Okay.
That is why I'm assigning one.
Okay. But there we can use classifier 1, classifier 2, classifier 3.
You can do it. But what this model, when you go, I'm just creating in one object so that it's simple for me. I will not write classifier 1, classifier 2. It's a very lengthy, right? It will take a space. So just I'm writing shorter form.
Got it.
Yeah. No impact. That also you can do it.
Okay.
Only I'm just creating object there. I'm storing this model.
And why we are not checking the training accuracy as well for the
I told you I will do it, but first I'm checking which model is the best model as per result, test result. Okay. And then I will check there or training also. Here also you can do it, but what happens is a very lengthy then. You have to check separately training test. So first I want to find the best one and then I will show you the training result as well.
Got it.
Okay. See, one thing, just tell me, if your accuracy is good, test accuracy is good, that means there is no bias, problem. What is bias? If anybody asks you, what is high bias? High bias means your training and test both result is less than 70%. Can I say less than 70%, 50%, 60%? Then we can say it's a high bias. Yes or no? Yes. If I'm passing here test data and test accuracy is coming 90%, 80%, 70%, that means what happened? High bias is not there because one result, how is it possible? One is coming higher, then it is not possible that high bias. High bias means both should be less. Then what is the chance? High variance would be. High variance, right? High variance means overfitting model. Right? Overfitting means if your training is 70% and test is 90%, we can say overfit model. So that part I will check it later. But when I'm getting good result, that means no bias problem, no underfitting problem. Are you with me?
Yes, sir.
Yeah. So that is why I'm not using training right now. But of course, you are right. Can I do it one by one? You are doing, then definitely you do it, my friend. Next part, my friend, model number 4. Model number 4. Here I'm going classifier 4 equal to random forest and my friend, what is the criteria? Can I put entropy? Okay.
Just one question. Will you go with randomized search CV?
I'll try. First, I will check by this. Randomized CV only you can go when your model is facing challenge accuracy problem. Right? If my already accuracy is good, then why you will go? If you are getting 90 and above, then do you go by randomized?
No.
So not required. You only go when my accuracy is both training and test is coming less than 80%. Then I can say, okay, definitely I have to improve my model. Yeah, this is the threshold value you can consider. If your accuracy is less than 80%, then you have to do grid search and randomized search. Yeah. All right. Now random forest entropy equal to classifier dot fit X train, Y train, and then my friend predict. So Y predict 4 equal to classifier 4 dot predict, and here X test. Now evaluation accuracy RFE and accuracy score Y test and Y predict And I say random forest is also done, guys. All my dear friend. Yeah, next.
So, sir, we are testing a random forest classifier on two criteria. First one is Gini entropy.
Linear entropy.
Gini entropy, yes, sir.
Yeah, sometimes entropy is giving better result because most of the numbers only. In the data set, you have seen everything is number. Gini is working very good when most of the data is character. Right. Now I'm going by the support vector machine. So you can say from sklearn dot support vector machine import support vector machine classifier. My friend, can I say model underscore support vector machine equal to support vector machine parenthesis bracket, and I'm just running this part for your understanding only. You will get kernel, guys. Here you can see by default sklearn is taking the best kernel. Okay, what is the best kernel, my friend? RBF, radial Bayesian function. If you guys remember radial Bayesian function. So see here what is coming by default kernel? Radial Bayesian function. But if you guys have learned hyperparameter tuning, right, support vector machine, then we have kernel equal to linear, kernel equal to sigmoid, kernel equal to polynomial, and kernel equal to RBF. Right? You can go here and you can see parameter. You can see the parameter. You can use linear, you can use polynomial, you can use radial Bayesian function, you can use sigmoid, you can use pre-computed. So I always prefer to go the default one, RBF, because it's a universal. RBF has a functionality to read 3D to 2D also, right? Any polynomial data there also it will, give the better result. So I'm just going by default one, and I'm not worried about that. I'm not creating a separate model kernel, all 4 model. If you guys interested, please do separately one by one. Only you have to change here kernel equal to inside parenthesis bracket, right? Kernel equal to linear, kernel equal to sigmoid, and kernel equal to polynomial. Define 3 models separately or 4 models separately, and then see which result is the best one. I can guarantee, my friend, you will get 90% time RBF is the better one. Yeah, sometime you will get other, but 90% time RBF is better. So I'm just going by RBF. You are with me, my dear friend? And other thing you can see here. Here other parameter is also there. If you guys see is what? It's my again hyperparameter is inversely proportional. If you guys remember the logistic and linear, this is the formula there. Mean of weight and weight 0, summation of I equal to 1 to n, actual value minus predicted value, and predicted value equal to mx I mi and minus b, yes or no, and their square, and plus you can do here lambda, and this value is again you can say xi and here 2. Yeah, so this lambda is a reverse. You can say lambda equal to 1 by c. Now what is lambda, what is c? I hope you guys have learned in your class. Okay, if not, then please. I can understand few people, they have not learned machine learning. They just started in day 1, they told me that I just started data pre-processing and other stuff. I have not learned it. So for them, my friend, if you are not understanding some technical things, then don't worry, you will learn it. Who has already completed machine learning and then you joined this project batch, and if you don't know, then please check your facts, learn this, watch my video, okay, and practice this, because these are the questions will come in interview also. Interviewer may ask you what is support vector machine, how hyperparameter tuning is calculated, right? What is the properties there, when we can go see what is the difference in CA lambda. So some technical stuff also they can check your knowledge. Anyway, so here I'm doing this part now. I'm writing support vector machine equal to model underscore support vector machine model support vector machine dot fit parenthesis bracket X train, Y train, and then predict Y predict 5 equal to support vector machine, not support vector machine model, support vector machine dot predict and X test. Evaluation, copy this, paste here. You can change this to support vector machine dot classifier and activity score equal to model 5. Are you guys with me till here, my friend? Next part is, my friend, model number 6. I'm using KNN model, one of the best algorithm for clinical sector dataset. So from sklearn dot neighbors import k neighbors gh bors neighbors classifiers. Then you can see model KNN equal to k let me write first this model KNN equal to k neighbor classifier, and by default how many is there? You can see this. I think by default 5k neighbor nearest value you will get it. Execute this. So by default neighbor 5 is coming. So let me write 5. Okay, or don't write it, by default system will put it. Here, my friend, again you can use elbow method if you decide only KNN, and you can find the best value. Okay, that part we will do later. Then my friend, can I write here KNN equal to model underscore KNN dot fit X train. I hope everybody is following me. You can see there is a pattern. I'm just what I'm doing, inputting, writing this, and just doing prediction and evaluation. Yeah.
Yes.
X train, Y train, then prediction, predict KNN equal to KNN dot predict, and you have to pass here X test data. And similarly, evaluation. So what is the evaluation? Copy this, paste here, and instead of saying basic KNN, no problem. Predict KNN. All right, my dear friend, take here. Are you with me?
Yes, sir.
Yeah.
Yes, sir.
Next part, model number 7 from sklearn dot naive-bayes theorem. Okay, naive-bayes theorem is very good model, guys. Can anybody tell me when you will apply the naive-bayes theorem?
Ad hoc request.
Ad hoc request. And
Ad hoc request and time limitation.
time limitation is ad hoc only, and
Text analysis, speech analysis.
whenever you have a text analytics, you can go by naive-bayes theorem. If they say you can go by machine learning, right? NLP also, we have a brilliant algorithm there, word to vec, right? We have a bag of words, we have TF-IDF, we have word to vec there, we have a BERT model there. But machine learning, naive-bayes theorem is very, very good. There are two things there in naive-bayes. One is Gaussian naive-bayes theorem, and another is called Bernoulli's naive-bayes theorem. So You can try both, see where you are getting best result. Gaussian, when you have more than or two classification values, then multi-class, you can go Gaussian. And when we have a binary there, then Bernoulli's is giving better result. That is what, as per experience, I'm telling you. But it's better you can try both. Like support vector machine, as per experience, I said SVM is kernel equal to RBF is best, but not necessary. Some of the case you will see kernel equal to linear also giving best result. So it's up to you. You have to go and explore it. All right, now my friend, NP equal to Gaussian Naive-Bayes theorem equal to Gaussian Naive-Bayes. This is one of the simplest algorithm, my friend. Only one formula there. Posterior equal to likelihood into prior divided by evidence or marginal. Only this probability value you have to remember. If you know Bayes theorem, Naive-Bayes theorem is done. Next, GNV equal to GNV dot fit X train, Y train, predict Gaussian Naive-Bayes equal to GNV dot predict, and here you can say X test. Now evaluation test. And here you can say GNV. And you can write here predict GNV. All right. Now I want you can apply the Bernoulli also. Model 8 from echelon dot Naive-Bayes per Bernoulli Naive-Bayes model equal to Bernoulli Naive-Bayes theorem, and then Bernoulli Naive-Bayes theorem equal to model dot fit X train, Y train, predict, say predict Bernoulli Naive-Bayes theorem equal to BNB dot predict X test, and then finally evaluation part. You have to spend time, guys. If you are doing manually, okay, you have to spend time. Okay, so this part is also done. Now next part is, my friend, what I'm going to do it, I'm combining all the model together. Okay, I'm combining all the model together. So you can say these are the basic ones. See, I'm not using XGBoost right now. Why? What is the difference in Random Forest and XGBoost, guys? Anybody?
So Random Forest is used in high variation and XGBoost for high bias.
High bias, right? So that's why I'm not using it. First, I wanted to check this whether this model is giving good or not. And then I will, if this is not, then I will go in the high bias problem, right? So I will focus on the restrictive. But first, you can do it. Now I'm saying here, combine all the models together.
So voting classifier.
Combine. Which one?
So voting classifier.
Voting.
Yes, sir. It will combine all the models.
Ah, voting. Yeah. Correct.
Yes,
So I'm just doing this, combining all the model by using.
There are variation in your audio. Sometimes it is
Classifier.
going low, sometimes it is going high.
Sorry.
Actually, there is a variation in your audio. Sometimes it is going very low, sometimes it is okay.
I don't know. This is complaint. I got it yesterday also. I got it, and today also I'm getting it. So maybe there is a problem in my headphone or what. I don't know. or some internet problem there. What is the problem? I don't know. Now it's audible, guys. I'm just speaking little loudly then. This is the last batch now, so I have energy also. My allergy is very less now because morning 8:30 to class keep going on. I'm getting only 15-20 minutes a day. Am I audible now, guys? It's better now, or can I speak loudly?
Much better.
Yes,
Much
it's
better. Thank
Yeah,
you.
it's better.
Yeah.
Okay. Now I'm using voting classifier. So I'm saying from sklearn dot ensemble import voting classifier. Okay. Now here I'm saying ensemble voting classifier equal to voting classifier and parenthesis bracket. Now what I'm doing here, let me copy this. First I'm running here so that it is enabled and it will help me. So here you can see, my friend, when I'm doing it, what it's saying first, estimators. Estimators means what are the model I'm using it. Okay. So copy this estimators and paste here. Estimators, right? Equal to, you have to say what are the models I have used, my friend. What is the first model? LR model, right? Logistic regression. So I'm saying LR. What is second model, my friend?
Decision tree.
Second model is decision tree, DT, right? So I'm saying decision tree. Second model is called decision tree, denoted by DT. What is third?
Random forest.
Random forest.
Random forest, Gini, information gain.
Information.
And here I'm saying RFI, right? Similarly, my friend, next what is this?
Random forest
RFE.
entropy.
Entropy.
So RFE, entropy. Next one is, my friend, what is next?
SVM.
Support vector machine.
SVM. So you can say support vector classifier and comma SVM. SVM. Next part is, my friend,
Gaussian.
Gaussian.
KNN.
GNB. KNN, right?
I guess KNN, yes.
So
KNN.
KNN. Can I say KNN? Next part, my friend, Gaussian naive base.
Gaussian naive base.
GNB. GNB, right? Then what is next?
Bernoulli naive base.
BNB. That is called BNB. What else? That's it only, right? After that, we are using voting equal to hard. Yeah, these are the parameters there. You have to go here and see this. Again, if you are not clear, please go and see this. What is estimator and hard or soft? So if hard uses predicted class level for majority rule voting. Else, if soft predict the class level based on the argument max. Right? So I'm just going by majority. I'm not going by argument. All right. So hard. And then, my friend, then you can see write it. Flatten transform. Do you want to transform? Yes, I want. This is behave just like a stacking, guys. So stacking I already covered in your session, so I'm not picking it. If you guys have not learned that session, then probably in the next week I will pick stacking them on the same model, but with regression problem. Because when I will go in the banking data set, you will get a regression data, continuous variable. All right, so this is my model. Now you can say model evaluation. EVC means ensemble voting classifier equal to EVC dot fit, and then you have to pass here X train and Y train. Everything I'm combining it and then I'm doing it. So prediction predict ensemble voting classifier equal to E or predict, and here you have to say X test data, and after that, my friend, evaluation matrix and accuracy ensemble voting classifier equal to accuracy store copy and paste. And here, instead of writing this, can I write here EBC? This part is done, my dear friend. Are you with me, everybody?
Yes.
Yeah. Now, what you have to do here? Just create. You can say list one equal to. Just write model line by line. So first is called logistic regression. So right here, logistic regression. Logistic regression. What is second? What is second, my friend? Decision tree.
Decision tree.
Decision. Random
forest.
Random forest Guinea.
What is fourth? Random forest
Entropy.
Next,
Support vector classifier.
support vector. Next is KNN, K nearest neighbor. And then next,
Gaussian naive Bayes.
Gaussian naive Bayes. What is next?
Bernoulli's naive Bayes.
This. And then, my friend, that's it, right? One more is there. The last one, what is voting, right? So voting classifier. All right, so these are the name I have given in the list one. Second, list 2 equal to the name I have given, my friend. Accuracy LR. Copy this. Paste here. Comma. Accuracy. Decision tree. Copy and paste. Next, accuracy, random forest, Gini. Next, my friend. Copy. Only things you have to be careful, write in a sequence order, okay? Otherwise, when you do the iteration part, it will throw it. Then, my friend, support vector classifier. Support vector classifier. Next part, my friend, K nearest neighbor. Next, K nearest, then Gaussian. Then base. Next is accuracy, BNB. Next part, dear friend. BNB, and after that, can I say accuracy ABC? Yes or no? Accuracy this. Everybody, you are with me?
Yes, sir.
Yeah. This is my list 2. Now again you have to go and say list 3 equal to. What you do here, you can just, gather all the classifier models. So here, first one is classifier, copy this. Second is, you have to spend time. Okay, when you wanted to compare which model is the best one. So you will not just build one model and immediately you can send to your client. When you are doing in data science, people are saying if you do this part, then you are doing crime actually. So you have to check all models, see the everything. Once you get confidence in beginner, if you are a new, then it's better. You can just evaluate with your senior, or you can check with your boss, say this is what I did. I evaluated everything. And this will also give a visibility, my friend. When you do know such type of job, your the management team, they also gain confidence. They will, you can build a trust with them. You will accentuate the positive relation with them. And any project will come, they wanted to involve you because they have a trust. That is the main factor there in the industry. So they have a belief that, okay, whenever you do such things, you will go by proper authenticity. You will not something that immediately you build and you can send them. So next is called support vector machine. Then model KNN. Next is after KNN, GNB. GNB, not this one. I think model I have written, right? Here I have written GNB. Here I have written model. See, in blunder I did it. GNB and then model. All right, and then finally my and go by model evolution. This part is clear, my friend. List 3.
Sir, I think in the estimators EVC, the list was supposed to end somewhere else, just on top. Maybe it will throw an error later.
Where?
In the EVC.
EVC here.
Estimators part, the list of estimators was supposed to end at
That
just before
square
voting,
bracket.
I think. Yeah,
Square bracket after BNB, it should end.
Yeah. After BNB, the square bracket needs to end.
After BNB, it should end.
Correct. Here we have to do a square, right? Now voting in this. This is the formula there, right? I have given here parenthesis bracket, so parenthesis would be closed. And this one would be one model. Yeah, estimated equal to this we have to. Thank you. This is what you are saying, right?
Yes, sir. Yes. This was
okay.
Yeah.
Thank you. Next part. You have to be careful, right? When you write these things, a silly mistake will throw all this thing, and then it's very difficult to check all one by one. So be careful when you write it. Next part, my friend, what you do, you can say data frame accuracy equal to PD dot data frame. I'm just creating whatever the result that come in a data frame, means table form, right? You can just write here, you can say method used, method used list 1, and then you can say accuracy equal to list 2. So what happened? First, list 1 will give the logistic regression and their accuracy part. Yeah, you have to say here print and just pass this data frame. Okay, one more line you have to say chart equal to SNS dot bar plot parenthesis bracket x equal to, say here, method used y equal to, you can say accuracy, and then data equal to data accuracy. Copy and paste. So you will get a visualization also. And then charts dot set x6 labels. And here you can see underscore x label and comma rotation is, I'm taking 90 degree. Okay, vertical line. Print charts. All right, now my friend, remove this part. Execute this.
Rotation is correct.
The rotation.
Rotation equal to 90 degree. Again error, which line? 83. Since support vector machine is showing not. So what is support vector machine I have given? Okay, caps I have given, right? So here you have to write support vector machine or classifier. SCM machine. All right, now go ahead, do this. Here, this is accuracy came, but I wanted visualization. Visualization also came, but why this is showing error? Line number chart dot x tick labels. Spelling is right. Just check this, guys.
Labels, get labels is, I think that needs to correct. LABEL.
In the bracket.
Inside the bracket. Yeah.
Label
LAB.
Here I have mistake. BEL, right? Labels. LABEL labels. Yeah, perfectly fine. Now it's coming perfectly fine, guys. Now, if you just give a glance, which model is the best one?
KNN and Random Forest intro.
Yeah, KNN is the best, guys. Everybody agree? You can see here the result also. Method used and accuracy used. Logistic regression, what is 77? Very pathetic. Decision tree 96, good. Random forest Gini is 98. Random forest entropy is same 98. Support vector 96. K nearest 98.3. So can I say random forest and support vector machine is giving same result?
Yes, sir.
Yes.
Yeah, both are exactly same. Gaussian, no. Bernoulli is a binary, so definitely binary will give better result than Gaussian. When I did it, overall, all model we combined it, we are getting 96. Since it's a classic clinical sector data, that's why I'm saying K nearest. But if I ask you, if I give you a choice, which is the best one? So will you go by this parameter alone, guys? Because there is an imbalanced data here. Will I go by this parameter?
No, sir.
Can I say this measurement I will not satisfy with this measurement?
Yes.
Yeah.
Yes.
You can do one more model.
Hey, missed me. Did that overwhelm you? Why don't you breathe in, breathe out for 30 seconds? Pause us for 30 seconds because taking a break is a must.
So let me try. See what is their result is coming. So can we do it as well, my friend? Yeah. What is the formula? From XGBoost import XGBoost classifier no model name called XGBoost, sorry. boost. Right? Copy this. You can see here model boost classifier, and then model dot model XGBoost dot fit x3 here. I'm getting this picture. Sorry, I'm not doing any grid search, randomized search. I'm not worried about this. Let me write here y predict XGBoost equal to model XGBoost dot predict and x test. Here you can see print x2 y test and y predict XGBoost. All right, so this one also I'm doing. So what is coming? 96.6. So will you go by Random Forest or XGBoost? Which one is better?
Random Forest.
Random Forest is the best one, right? Okay, but right now accuracy is not only the parameter to judge your model, guys. So can I do other part also?
Yes.
Yes, sir.
Yeah, we have to do a confusion matrix also. We have to build a classification report as well, and ROC and AOC curve as well.
Yes, sir.
So shall we do it? Other parameter as well. Other evaluation method. So what you do, you can say from sklearn dot matrix in both ROC receiver operating characteristic, AOC area under curve, and what else? That's it, right? Other I have already imported. So now, my friend, what I have to do? I have to do, guys. Shall I apply all?
No, whichever is giving the best comparable result.
Whichever the giving best, that only we have to take it, right?
Only
So,
2-3 models comparable
so
results.
one can I consider Random Forest? Both are same, so any one you can take it. Can I take entropy because it's a all number? And under, can I take k nearest neighbor?
Yes.
Yeah.
Sir.
So
Yes.
go here. What is the mean? Accuracy, predict, and classifier is this RFP. RFP and KNN equal to KNN only. Please copy this. Please copy this. Random Forest estimator. This. Okay, this is called Random Forest entropy. Other one is KNN. There is KNN. All right. Can I check training also, my friend? Can I check training as well?
Yes, sir.
So can I say here train, and here, my friend, can I put here train, X train, copy this line, paste here, and can I say here test, and here also test. Similarly, copy and paste, and KNN, train, and test. This is called train, test. Execute this. Now print confusion matrix y train, comma y predict train, copy, paste, print, give some space, and 5 and this. And here, my friend, test. Are you guys able to connect me or not, or just seeing what I'm doing?
Yes.
Yeah. So this is my random forest confusion matrix, copy paste, and this is my KNN train confusion matrix. What confusion matrix will do? It will tell you how many false negative and false positive you have predicted. Here also you will judge which model is the best model. Now, my friend, when I use the random forest, training is giving 100%. You can see 0, 0 means false negative and false positive is giving 0. And when we test it, only one error is coming. Yes or no? In the confusion matrix? Yes, when I did the training this, when I train the model with KNN, I'm getting 7 false positive, 0 false negative, right? And here only 1. So test is okay, absolutely right. But training, I can see random forest has an upper hand. Yes or no?
Yes.
Everyone?
Yes, sir.
Yes.
Okay. Now please copy all this thing. You can analyze this random forest again. Paste here, and instead of writing confusion matrix, you can say classification report. Copy this, paste here. Similarly, execute this. So this is what I am getting here, my friend. What is your understanding here? Random forest is giving 0 and 100% for training, and here 0 is 97, 100, 98. 100, 97, 98. Yeah, this is my random forest data is. Same thing I'm doing with K. Give a cross competition to each other because it's a clinical sector data. Otherwise, if other data, they're banking, finance, random forest, immediately blindly you can go and use the random forest. But here, since it's a classification, so that's why I'm going in detail. Now see this, guys. What happened, my friend? This part training is given 94, 1 and 97. Okay, 1, 94, 97. Here 97, 1, 98, 100. This, which one is more liable, guys? One upper hand I can see here clearly in confusion matrix. Training is giving absolutely right. And test only one error. Yes or no? Can I say as per confusion matrix, random forest is best? As per confusion matrix, random forest is best. Here test is okay, but training, can I say here 7 error happened?
Yes, sir.
Now next go to the classification report. What it's saying, classification training is everything is 100 and test is 97, 1 and 100, 98, right? Just go and test, you can give 97, 100, 98. Can I say here also upper hand, guys? 197, 98. What is coming here? 197, 98. Both are same, I think. 97, 100, 98. 97, 100, 98. Both are same, right? But in training, everything is coming 100 here. Everything coming here 100. 1, 1, 1. Means random forest, when we have given a 500 tree, that is giving the better result. And here 94. Slightly variance, but definitely if you go very minute, then you can say random forest is the best one. Otherwise, KNN is also a good. Yes, no?
Yes, sir.
Everyone?
Yes, sir.
Yes, okay. Okay. Now what we have to do here, my friend, what we have to do here, you can just go and do the ROC curve also and see what is happening. So shall I do ROC curve as well, my friend?
Yes.
Yeah, the final result.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Next part is called final result. ROC and AUC. Now, ROC and AUC, there are three properties there. If you guys remember, this is called, my dear friend, false
Positive.
positive. False positive rating. And this is called true positive rating. This line is called area under curve. Okay. If your line will go above the AOC, then you can say your model is very good. If your line will cross this line, then you can say my model is underfit. Not underfit, imbalanced data. Right? If you don't handle the balanced data, then it will come, here. And if the value will come, ROC will come down, you can say reject. This is worst model. Okay, so this is also one of the parameters which will give you. So three scenarios here. If ROC curve is upper, right? What is the target? Predict more true positive, upper the true positive and lower the lesser the false positive, then my model is good. That is the understanding, guys, my friend.
Yes.
Yeah. So please go and do this part. See what happened. Something Simi is saying, sir, why we are not considering recall and precision? Simi, I have already considered, no? Didn't I? This one is recall and precision only, no? Okay, perfect. Now ROC, my friend. So here I'm saying define plot ROC. Just write here model, comma, extreme or X test, comma, Y test. And you can say probability equal to model dot predict underscore probability numpy array next you can say prediction equal to probabilities false positive rate, comma, true positive rate, then threshold equal to
I have a
ROC
question.
curve.
Sir, suppose in this scenario we are getting accuracy around 98%, and client says like this is a clinical sector data set. So client says I want accuracy up to 99 or more. So how can we move from 98 to 99 even after applying these all the models when we are getting accuracy?
Have you learned K-fold method?
Yes, sir.
Use K-fold method. Apply this. You wanted me to write it?
No, sir, it's all right.
You can do it automatically. It will come 100%. 98 already there. What is the big deal to improve 1 or 2%? Just say K-fold equal to 10. Yeah, this is the package there, my friend. You can say from sklearn dot model selection.
It's all right, sir.
Import cross val. So that's it. And do this. Okay, you can try it. Already knowing and then asking, no? ROC, AOC equal to AOC. And here you can say false positive rate, comma, true positive rate. Now do a visualization, say PLT dot title. And you can say receiver. Receiver operating characteristic PLT plot false positive rate, true positive rate, bold label equal to area under curve range 0 to f and then percent C AUC. Again, you can see here PLT dot agent FOC equal to lower right, and then PLT dot plot. What is the range you wanted to give? 0 to 1 for x-axis and 0 to 1 for y-axis, and how this will come? R dash dash, red color, and it will go in dash dash. Let me see this. PL2 dot x limit to 1, PL2 dot y limit 0 to 1, PL2 dot y label. Just give label name true, positive, PL2 dot x label right here, false, positive, and then PLT dot show. All right, my dear friend. Now here, instead of going model, I think I will write here random forest entropy. Or if you go by KNN, you can just say KNN. All right, please go ahead and do this. This is done. Please copy this line, plot ROC, do it here, and just pass it. Random forest, this X test, Y test, execute this. See here, my dear friend, this is what you are getting it. False positive rate, true positive rate, and you see what is the boundary is saying, my friend, what is they are suggesting? 84%. Means they are saying you have to do here. This line. See this line my model is suggesting. 84 somewhere is this. Everyone. This is the cutoff value we are saying. So positive is 84 and negative is less than 40.
Yes, sir.
All my dear friend, you are with me.
Yes, sir.
Yeah.
Sir.
So could you please explain this chart again?
So chart
Like
this line, this is called area under curve. Area under curve. I hope you know the history, right? How it comes.
Yes, yes.
Yeah, this came after World War II. This word is actually data science. Most of the word taken from different terminology. Ensemble actually comes from music background, right? That's why the meaning is ensemble. Earlier it was people were using in music, right? When any music generation happen, you can see lots of equipment there, singer there, right? So that's all get ensemble, and then music generation happens. So ensemble model is actually come from there. Now AOC and ROC come from World War II, right? It's actually electronic physics there, right? So whenever they pass the missile, they are finding how the direction is going. So if above bias they are hitting the target, then their model is fine. So what is this? This line is called AOC. Okay, I'm just saying very simple approach. Any government every year, you can see in the Indian government what they are doing. Every first fab, they are giving a budget, fiscal budget. Yes or no?
Yes,
in
sir.
fiscal budget, you will see the same chart. This chart is called AOC, or this line is called AOC line, area under curve. And here it will come population, and here it will come income. You will notice that. And the population is coming like that, my friend. So here 90% population, they have only 20 to 30% currency, and only 10% or 20% maximum there. They have 10 to, you can see approximate 20%, they have 80% currency there. Okay, what government agenda is, whenever any government form, what they are saying, the who is in BPL category, they will become a APL. Who is in APL above poverty level, they can become a middle class. Middle class become a rich man. But it's only on paper, right? It's not happening. You have seen, you know, lower income people, their generation by generation, they are poor only. Poor people remain poor, richer people remain rich only. In data science, different thing happen, right? Data science, actually, we are saying if any model will go below that line in a budget, we are saying Gini index. Okay, Gini index. So wherever you understand Gini index, please understand they are, you know, assigning population versus income. And wherever you heard this ROC, receiver operating characteristics, means we are calculating false positive versus true positive. What is my agenda? We have to predict more true and less false. Meaning is, when you do this, when you build this part, my friend, this is 0 and 1, this is 0 and 1. Let's say this is my actual value and this is my predicted value. If predicted is 0, can you put NN and PP, positive, positive? Here 0 and here also 0. Can I say true? Here 1, here also 1. True, and rest is false. This is the confusion matrix, guys. What is your intention is, what is your intention is, this value will come here. Yes or no? No, sorry, this value will actually come here. This false positive will come into false negative, because actually it is a negative, but you are saying they have a cancer or they have a problem. Right? So this positive will come here and this false negative will go here. That is the agenda there. So this model is assigning how many true positive and how many false positive is there. Now, when you predict it, what is my optimal value? I have to choose it. So this is giving optimal value. AOC equal to 0.84%. This is the optimal value we are considering. Or you can say cutoff value, where my optimal value is 84% we are predicting, and 35% we are predicting false. That is the variance is coming. If you go by only, it's an imbalanced data set, right? If you go by accuracy only, you have no visibility. That is giving 98.3% accuracy. That means you are saying only 1.7% error there, right? When I go confidence value, confusion matrix, then also you are getting 100, 197, 94. But what is the actual, when you go by the average one, what is the actual positive data we are getting it? So here we are saying 84. Are you with me?
Yes, sir. Got it. Got it. Thank you.
Yeah, so that is what is the AOC concept there. Now, your model is ready, my friend, and your client will ask you which model. Now you can do an intuition. Okay, everything you did it. Now it's your choice. You decide which one. Just forget about, for the time being, it's a clinical sector data. Okay, if you know it's a clinical, blindly you will go and use the KNN model. But if it's not clinical, if you get a financial data, you will try this part or not, because financial you don't know. So now if you get a financial data, will you able to do it this part? Tell me.
Sure. Yes.
Yeah, and then you have to choose which model is the best one. And here, if you are doing a financial data set, guys, where you will trust more? In a generic, I'm asking you, will you trust random forest or you will trust distance matrix?
Random forest.
Yeah, I never ever try to accept KNN except clinical sector data set. Why? Because this is lazy algorithm. You guys have learned, their name is called lazy algorithm. Have you learned theory? K nearest neighbor?
Yes, sir.
Euclidean distance, Manhattan distance, Minkowski distance, Hamming distance, cosine similarity. This is called algorithm, nearest value. If your neighbor is IS officer, that doesn't mean you are also IS officer, right? This fits only in clinical sector. If your glucose level is more than 150, you have a diabetes. Other person, if they also have more than, they also have diabetes. Then we follow that concept, right? That's why we can say we can trust in clinical sector. But finance sector, I will not trust. Banking sector, I will not go by this. Yeah. So here, if you just think in a different way. My purpose is not to teach you only this part. Any data set you can go and you have to draw this line. And here you can decide which is the most best one. So one parameter is accuracy. Second, you can do a confusion matrix. Second parameter. Third, you can do a classification. Fourth parameter. And then finally, you have to visualize and see what is the final cutoff is coming, including everything. What is the area? What is the true positive? What is the false positive? Everything you can do it. And then you have to find it. And then you can conclude that random forest is the best one. I hope you are with me. All my dear friend.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah?
Sir, just
Now-
one question.
Hmm.
Sir, actually,
Go
if I'm planning to deploy my model, so what are the features like I need to display on the
I don't know. I don't know.
HTML page?
I don't know. Sir.
Okay.
These are the questions why you are asking right now. Right now, focus on clinical project only.
No, sir,
You are with me on LinkedIn or not?
Yes, sir.
You have free time, no? You are not busy like me. You can chit chat, no? Just ping me, disturb LinkedIn on Monday to Friday. Okay, at least I know your name. Then also you can say hi. I'm waiting for your response. Can you please respond? Do disturb me. Definitely, I will come back. Now we have only 12 minutes. If I pick your question, I think I will miss the deep learning part. Can I do quickly, guys, deep learning also?
Yes, sir.
Sure, sir.
Yes, please. Yes, please. Yeah.
All my friends, so that next going forward, whenever you build, you will do like that.
Sure.
Yes.
Okay. So now, same model, I'm using deep neural network. By the way, XGBoost is also very good, no? It's giving 96%. It's not bad. Deep neural. But deep neural network, if I will do here, I made a mistake. I'm using Jupyter Notebook. Ideally, I should use Google Colab. Yeah. So then it will take my system, get hanged, and it will not work. Okay. I'm not doing deep learning then, guys. Or can I import in Google Colab and then I can show you?
That would be
Yes,
great,
sir.
sir.
Yeah.
Yes, sir.
Yes, sir.
Do that, please.
I can do that part also. Just 2-3 line code only. Let me get the Google Colab.
Is it worth using deep learning here because data set is very small?
Very small. Yeah. That is. No, I'm not willing to tell you the data set. I wanted to teach you the approach. That's my intention. No. My intention is to know the approach. If you get big data or a small data, if you know the approach, you can do it. You already know when we have a huge data set, I will go by deep learning. When we have a less data, I will go by machine learning. Now tell me, machine learning, if you do manually, you will able to do it or not. Or you already learned PyCaret, you can also do automation kind of things.
Yes, sir.
All my friend, yes or no?
Yes, sir.
Yes, sir.
Yeah, so you know that,
Yes,
right?
sir.
You can try it anytime. Okay, now let me do it then. Google Colab. Upload my data set, project, healthcare, project, detection, Parkinson data set. Okay, so I have imported the data set. Let me setting my working directory. Hardware is GPU, graphical processing unit. Import the data. Let me put the copy and the top. Yeah, changing this. That's it. Okay. Now rest everything I'm taking as it is. So let's run the code. This done. Now import the data set. Now this is not required, not required. I can do it later. Not required. Not required. But I'm not doing this part, my friend. You already know that. I'm just going in the bottom. Not required. Yeah, this one I'm doing X and Y. Or something. Yes, you can do it. Feature scaling is mandatory in deep learning. What happened?
Import, sir.
I did also have input, no? Import done. Then we have to do PC also. PC is not required in deep learning. I'm directly going and doing this. Given PC, so it's only. Okay, this is what I did it. Now I'm building a deep neural network model. So you can say from import TensorFlow as if from TensorFlow import Keras from Keras dot layers import dense from Keras import sequential. I can do many more things in deep learning, my friend, but I'm just telling you the basic how you can build classification and regression problem. If you guys have attended my deep learning session, then you know what all things you can do it, right? Is there anyone there in our 12:30 to 3:30 batch in this batch? And morning 8:30 to 10:30 batch, 8 to 10?
Yes, sir.
Yes, sir.
So you know, right? You are expert then. So just for reference, I'm writing it. You know, who has not attended my session, you can see, you can also try to do this part. So many parameters there. I don't want to discuss that parameter. We have a brilliant activation functions there. We have optimization techniques there. We have earlier stopping there. We have dropout there. So all these things you can apply. But simple architecture, I'm building it. I'm saying model equal to sequential. Then my friend, model dot add dense. And here I'm just saying 32 activation equal to ReLU, and then input dimension equal to only dimension there, my friend. What is the dimension for X? It's already there, right? 8 there. You can see 8 column, right? So this is my X.
Not
Not
eight column.
Yeah,
22.
22. I have right here dimension equal to 22. Okay. Now again, copy all this thing, paste here. Okay. Now you have to do copy and paste, and here final output is 1, and this is my binary class. So say sigmoid. Yeah. If you know hyperparameter tuning, you can go and apply the hyperparameter tuning also, my dear friend, so that it will tell you what's best hidden layer, best neuron value. And then finally you can say model dot summary. Let me check how many parameters my model is creating. Error, what happened?
One more parenthesis.
Parenthesis at last.
Here I have given one. Parenthesis 1 and 2. All right. So how many parameters get created? Yeah. So see here 100, 825 because data set is very less, right? So that's why only that much parameter came. I didn't use batch normalization, guys. You can use batch normalization also, early stopping also, vanishing gradient concept also. All these things you can try. I'm not doing, I'm just telling you. Now you have to just build a model, final model. You can say model, compile, and optimization equal to opti, or I'm not optimizing because data is very less. So I'm saying loss equal to binary cross entropy, and then matrix equal to ratio, and then you can say model dot fit x train, y train, then batch size equal to, let's say I'm writing 32, and epoch equal to 100. Here my friend, validation data equal to x test and y test. That's it. Execute this. See, deep learning is doing an amazing job. Okay, 200 all done. What is accuracy I'm getting, guys? Training accuracy 99. What is my test accuracy? 98. Can I say better than machine learning?
Yes, sir.
My friend,
Yes.
are you with me?
Yes, sir.
Yeah, so this is what you can do. The same model, just I have written 5-line code. One hidden layer, 2 hidden layer, then compile the model and fit the model. That's it. Finish. Deep learning done. You are getting a very brilliant answer. And whatever you can do. This is just when we have a less data. If you have a huge data, same thing you can apply. Of course, there are some parameters there. If you guys learn, you have already taken deep learning session, then you know it. If not, then don't worry. You will learn in class, but this is what you will do, the final things. I hope you understand the end-to-end perspective, my friend, how you will handle the classification problem, end-to-end all models.
Yes, sir.
Everyone. So this is all about, this is not applicable only for, healthcare data set, but everywhere you can try it. But of course, there are some other things there. So next week, I will come with a different domain, my friend. Okay, what domain? Anybody have any specific? Can I go by banking or finance?
E-commerce.
E-commerce. Okay, so I'll go in e-commerce then. Yeah, so next week we'll pick e-commerce data set, guys. Okay.
Hey, did you understand? Because, as I said before, the best part of watching videos is you can rewatch it if you don't understand. Yes. Shall we begin with the best part? Answering all your questions for the best you.
Boosting and bagging are both ensemble learning techniques used in machine learning, but they differ in their approach and how they combine multiple models. Boosting. Boosting is an ensemble learning technique that combines multiple weak learners, simple models that perform slightly better than random guessing to create a strong learner. The key idea is boosting is to train weak learners sequentially, where each subsequent model focuses on correcting the mistake made by the previous models. It assigns higher weights to the misclassified samples, forcing subsequent models to pay more attention to those samples during training. The final prediction is made by aggregating the predictions of all the weak learners Example of boosting algorithm includes AdaBoost, gradient boosting, and XGBoost. Bagging, short for bootstrap aggregation, is another ensemble learning technique that also combine multiple models, but it does so by training each model independently on different subsets of the training data. Bagging involves random sampling subset with replacing from the original training data to create multiple subsets of equal size. Each subset is then used to train a separate model. The final prediction is made by aggregating the prediction of all the individual models, such as taking the majority vote in classifying or averaging the prediction in regression. Random forest is a popular bagging algorithm that combines decision tree. In a classification problem, we want to separate different types of things based on their characteristics. Kernel support vector machine is a special algorithm that helps us to do this more accurately, especially when the things we want to separate do not have a straightforward dividing line. Imagine you have a bunch of dots on a graph and you want to divide them into two groups. Kernel support vector machine uses a clever trick by transforming the graph into a high dimensional space where the group can be separated easily. It's like lifting the graph off the paper and into three-dimensional space. Once in the higher dimensional space, KSVM find the best way to draw a line or surface that separates the group as much as possible. This line or surface is called as decision boundary. The idea is to have as much space as possible between the groups so that they are well separated. KSVM also takes into account the importance of certain dots that are close to the decision boundary. These dots, called support vectors, help to determine where the decision boundary should be placed. By paying attention to these important dots, kernel support vector machine can make a better decision. One advantage of KSVM is that it can handle more complicated situations where the group are not easily separated by a straight line. It can handle curves, loops, and other complex shapes as decision boundaries. KSVM is also good at dealing with situations where there are lots of features or characteristics to consider. It can handle situations where there are many factors to take into account when separating the groups. Furthermore, kernel support vector machine is designed to handle outliers, which are unusual or extreme data points that might skew the result. It focuses more on the overall patterns of the data rather than being influenced too much by a few unused points. Overall, KSVM is a clever algorithm that helps us to separate different types of things by finding the best way to draw a line or a surface between them. It can handle more complex situations, consider many factors, and is not easily fooled by outliers. Stacking, also known as stack generalization, is an ensemble learning technique that combines multiple predictive models to improve the overall performance and accuracy of prediction. It takes the output of individual models and uses them as input to a higher level model called a meta model, which makes the final prediction. Stacking offers several advantages, such as it can provide better prediction accuracy compared to using individual models alone. It is flexible and can accommodate various types of models, and it can handle a wide range of problem types including regression and classification. It allows for the discovery of more complex relationships and interactions in the data. However, stacking also required careful considerations, such as it can be computationally expensive, especially when dealing with a large number of base models. It requires a sufficient amount of data to train the base model and the meta model effectively. Care must be taken to prevent overfitting by using appropriate validation techniques and regularization methods. In summary, stacking is an ensemble learning technique that combines the predictions of multiple models to improve the prediction accuracy. It involves a diverse base models using their predictions as input for a meta model and making final prediction based on a combined results.
Yes, you did it. I hope you find this project useful. I'm sure it did, because gosh, I feel like I am about to become a data scientist myself. I'll see you guys soon with a new project just for you. What do you think will be our next project? Maybe e-commerce? I don't know. Let's see what our next video brings to you. Stay tuned.